All right? So that's like 3 people. That's not as many as I was hoping, but just hold on to that, all right? Be something cooler here. All right? So that's this slide, which I totally skipped over. Okay, so this talk is about title cycles, which is a pattern-based music programming language which is written in and lives on top of Haskell, which is a strongly statically typed, purely functional, lazily evaluated, compiled general-purpose programming language, and sort of how to combine them and make some compositions on the fly. So Haskell is a functional language, and if you talk to me and you start getting me to geek out about programming, you'll know that I believe that functional programming is just the holy grail of programming, because you tell the computer what to do, and it does it. But functional programming, or FP, could kind of get its own talk in this regard. So we're only going to go over enough to sort of understand what's going on with Haskell. So lists are kind of cool, right? Lists are nice in general. So in an abstract data type sense, they're kind of quintessential. Think back to the good old days when you had a data structures or an algorithms class. You've got arrays, if you want really efficient structures. You've got linked lists, which typically elicits memories of having to code them by hand, on paper, on an exam, in a data structures class. You've got array list, if you love torturing yourself with Java. You've got this thing, or nil, if you know what that is, then you probably think you're pretty smart, and so on. So functional programming is kind of the best way to work with lists, and it's a big reason of why title cycles works on top of Haskell. Because at the end of the day, functional programming favors recursion, and lists are basically defined recursively. If we want to read this, a list is this thing or a thing and then another list. So that's a little bit of an academic look at it, but to read it in plain English, a list is either empty or it contains an object and the rest of the list. So what that means is that any entry in a list is followed by the rest of the list, except the last item in the list, which is followed by the end of the list. So incidentally, just as sort of a side note, this is all of the language list. If you ever have to program in Lisp, it's pretty simple, because as long as you understand the syntax of a list, you're pretty much set. So given what we know, we can build lists by hand. So the colon sort of represents like almost insertion into a list. So 1 going into the empty list gives a list of 1. 1 going into the list of 2 and 3 gives the list of 1, 2, and 3. The list of 1 and 2 into the list of 3 gives the list of 1 and 2 into the list of 3. And I guess HELLO into a list gives a string. That's kind of interesting. So the important takeaways here are that Haskell is strongly typed and as such wants all of the things in its lists to be of the same type. And second, lists of characters are synonymous with strings. So how does this connect with title cycles? We want to start making music. Well, if we want to start talking about music, first we need to define some sort of, if you will, metadata about our piece of music, such as tempo. So title measures cycles per second. A cycle is something like a measure. And if we want to talk about something like beats per minute, then we kind of need to convert from one to the other. And that's pretty easy in the sense that we can code. And essentially what we do is 120 beats per minute divided by 60 seconds per minute divided by 4 beats per cycle. And that works out to be a lovely 120 beats per minute. So, it's worth noting that this is not our smallest grain of timing either. We can and will further subdivide this. So what is a list in music? Well, it's something like a lick, or a riff, or a melody, or a beat, or a bass line. Essentially, it's some notion or structure within which we can capture things like pitch, and the type of instrument we're playing on, and the timing, or the rhythm, right? Rhythm is critical. So if we want to have a list containing musical information and title, we need to capture these things at a bare minimum. So here's where I pull out an example. So there's this really famous jazz riff called The Lick. Who was that? This guy knows what's up. So I can do something like this. Bear with me here for a minute. Tilde here. And we're going to put a tilde here. And then hit this. And now, this is going to give us the following. All right. So here's what's going on in a nutshell. What we've got is this sort of statement within which we've got some words and stuff. So RP over here is a sample reference. It points to an audio file that is played back, right, according to these numbers. The tildes that I inserted are rests, and rests are simply sort of like a node where you just don't play. Then the next important thing is sequences. These are sort of how we contain our musical information. So that would be this guy right here. And in fact, the entire string and the internested square brackets are both sequences. And the really cool thing about sequences is that elements of a sequence will all have the same value within the sequence. And this is really interesting to think about, because it means that this rest over here and this rest over here have different values, right? This rest has the same duration as all of the rest of the numbers in the nested pattern, whereas this one has the same duration as the entire pattern in square brackets. So, to put this in musical terms, this tilde represents an eighth rest, whereas this tilde represents a half rest. And then we have a couple of functions here. S is simply a function that sort of translates sample references into actual sound. Slow is a function that will essentially play the pattern half as fast. Up is a function that will take a list of numbers and turn them into musical pitches according to the scale. D1 is just sort of like a sound card output. That's all you really have to think about it. Don't think about it too hard. So, to put this in a really hand-wavy way, a sample reference is a sample name, optionally with a colon and a sample index, so we can index different samples within the same category. We'll see more of that later. And then a note is either a rest or a sample reference. And then notes are either nothing or a note followed by more notes. And then a pattern is either notes or notes surrounding the pattern. So patterns kind of have a recursive structure just like lists. This is kind of cool. And this is no coincidence because Haskell has really powerful functionality built in for defining one's own data types according to these sorts of rules and extending the language with your own data types. So, title cycles works according to a pretty familiar architecture, client-server, right? So, what it is a client usually interfaced by a text editor or a command line interface, which is connected via a port to a server, which listens on said port for messages to be evaluated. So, ports are nice because they're general. We can use them on the same machine, different users on the same machine, across different machines over a network, whatever. So title does this in the following interesting way. The client is a Haskell interactive session called GHCI, or the Glasgow Haskell Compiler Interactive Mode, which communicates with Super Collider, which is a significantly more complex music programming environment. This is what actually talks to your sound card, and it runs on top of it a sampler called SuperDirt, which actually processes the messages and plays samples. So, now let's talk about title cycles and writing music for real. So, the general structure of a function call and title looks something like this. There's a lot of parentheses. If you use functional languages, you know that it's a parenthetical nightmare. But Haskell has a really nice shorthand that is the $, which just takes everything to the right of it and kind of puts it in parentheses. So this makes this considerably more readable. So we can talk about what all of these are now. So the D function, D1 through D9 are, like I said, just sort of like outputs. Pattern effects are transformations on the patterns themselves, things like reversing the patterns or repeating them. The sound function, like I said, translates sample references into a pattern to be later evaluated. And then synth effects are things like filter cutoff, reverb, that sort of thing. So let's go ahead and give some examples of such functions. So we got this lick. But if I wanted to reverse it, that's pretty easy. That's a pattern effect. And then maybe I want to add a filter, right? I'm good. Alright, maybe I want to do something a little more crazy. Let's do some stud, which is sort of like a time delay. Alright. Let's do something even crazier. A function called juts. Stereo effects in the left and right channel. Yeah.
So the juts is the harmony?
Sorry?
The juts is the harmony?
Juts is doing something where it'll sort of shift the pattern to different positions in the left and right channels. Okay. In stereo. Iter4 is just telling it to shift the pattern by 4, essentially. So, this is pretty neat, I guess. But let's think about some other interesting examples. So, we're programming, and one can usually think of things that you can do with programs that a human can't do. So, if we think about sort of your traditional composition or performance, there's some cases where you might want to do things a little bit more crazy. So remember the whole thing about random number generation. I happen to have some drum breaks that I processed. So I'm going to go ahead and play those for you guys. So what's happening here is RAD1 is my sample reference, which stands for really awesome drums. And what that's going to do is this N function here parameterizes the sample selection. So I've actually got 8 distinct samples within the RAD1 folder, which I can index based on a numerical parameter within the language itself. Of course, it sounds a little weird because it's not up to tempo. But here's the thing. Run just sort of generates a sequential list from 0 to 7 for indexing the samples. IRAN will do a random sequence instead. We just invented breakpoint. That's it. That's one line of code. So the first question that someone like me might ask is, how can we make this even more crazy? Well, let's do something like this. I'm going to use a function called slowcat. What slowcat does is it will take a list of sort of these functions. And it'll evaluate them kind of one by one. You'll see what I mean once I've got this working. So, 1, 2, 3, 4, 5, 6. So now it's just going through all of my drum break folders sort of in sequence. And that's kind of cool, right? But we can do a little bit better, right? So we can add some pattern effects. Namely, what I'd like to do is use a function called, not stat, spread. Spread is sort of a classic example of a higher order function or a higher class function in a functional language. A higher order function is a function that takes a function as an argument. Now, if you come from a more OOP background like Java and C#, that probably sounds a little crazy, but thinking of functions as data is kind of quintessential to functional programming. So, spread takes a function as the first argument, and then a list of parameters as the second argument. And what it'll do is it'll just sort of, in sequence, apply that function according to those different parameters. But there's kind of a neat trick. Remember what the $sign is. The $sign is a function which takes everything to its right and applies parentheses around that. So if I set $sign as the function, then my list can become a list of functions which I will apply iteratively over the pattern. So you can use stuff like maybe some rev, maybe some accelerate, maybe some course. Shop, some stud, and some jumps. All right, and then we close our list over here. $sign, kind of pipe that into slowcat. How's that sound?
No, really.
Yeah, that's pretty alright. So, you might be wondering where these samples are coming from. The truth of the matter is, title cycles kind of come with a lot of samples by default. It's like way more samples than any one person can really hope to go through in a lifetime, I think. Which is why I tend to like to prepare kind of my own samples ahead of time, and then I'll use those kind of instead. But there are some nice samples that I like to use. So this is where I really like to use sort of my own samples. You'll see that a lot of the stuff that's prefixed with J or JSON is stuff that I've made ahead of time. And this is
Really awesome drums.
really awesome drums, pretty awesome digital synthesizers. But yeah, really, this is kind of pretty neat stuff. So that's a little bit of music. That's the kind of stuff that you can do with this. Alright, so at this point, you're either kind of interested in this and you maybe want to try it out yourself, or